Hello, my name is Austin Carlisle, and I'm the team lead for Capstone Team in Your Orbit. We worked on Project Cloud-based planetary ephemerides, and I'm going to be showing our final acceptance demo. I'm going to just be working off this document just so I make sure I get all the requirements correct. And so the first thing we're going to run is the web service functionality test, and to start it off, we're going to start the web service. Before I do that, I need to deploy the DynamoDB instance. So we're gonna go to the AWS console here, go to the CloudFormation resource, and we're gonna hit create a stack. I'm gonna choose upload a template file. We'll choose it. It automatically opened to my YAML files. I'll choose my Dynamo YAML file. I'll hit next, and then I'm gonna name it ISD. Hit next. Everything's good. Hit next. It's already set up perfectly, so I'll just hit submit, and then we will wait till it runs. So it's just generating the stack and deploying the instance right now. And we will wait. All right, perfect. So it says it created everything. So we'll go over here and check. We'll check our DynamoDB tables, and it generated an instance. And now we will run a live item count, and we can see that we have 0. All right, so that's the prerequisites in order to running our web service, which is step 1. So we're going to start our web service now. So I'm going to run the command. Let me grab it real quick. Excuse me, sorry about that. I'm going to run the command to run the web service. And perfect, we can see that it has started up and it is now listening on this IP and port. That was already in my clipboard when I tried to post the command because I already ran a demo. So that's what that was about. And now I'm going to show a separate folder with the tester client and the test label in it. So over here, I already have another tab, and I'll ls. This is the folder that has the ISD web service and everything that this is running in. And we can see that we have a test folder. So we'll go into the test folder, and we have a label file and a test client, and then just like a README explaining how to use it, but that's not important for this demo. So what we're going to do is we are going to now run the tester client with the test label. So we'll go Python test client, and then the name of the test label, and then we have to give it the URL that the web service is running on so it knows where to send it. So perfect, it sent it. And now we're going to show ISD generation. So if we switch back to the web service, you can see all this stuff. So we can see that it was listening, and then we sent it a label file. It read that label file, and then it began to process it, and it ran through every driver and failed until it hit a success status, which will be coming up soon right here. Sweet. And then it generated an ISD, and it printed out the whole ISD generation we can see right here. And then it ended that by telling us that it returned it correctly back to the client, got an OK status back. So now I'm going to show the ISD was returned in a generated returned ISDs folder. So now if we go back to our test folder, we ls again, we can now see that we have a returned ISDs folder. And we'll go inside, and we can see a test isd.json. And I'm just going to run a stat thing on there, which will show us all the information. We can see that it was just created now at 1:30. So we just got this test file back. It was just generated. And now if we believe, yes, open the ISD in a text editor. So if we open this ISD, we can see that it is a perfectly generated ISD file. And now this isn't actually in the acceptance demo grade sheet, but just to show off the caching thing, I'm going to run this again. And so it ran, and now if we go back, this is our last response, the first time when we generate ISD. You can see when we sent back the same file, it read the label file, and instead of generating an ISD and going through this whole process, it just returned it right back. Now if we go back here, and we go back to our returned ISDs folder, and we run stat on the test isd.json again, we can see that it was created at 130, so it's the same file, but it was overwritten at 132. So we got back the same ISD, but rewritten to the same file, so it didn't generate a new one. And we can see from the web service that we merely returned it. We didn't go through the whole generation process. And now we can even prove this again. It's the same exact fully formed ISD file. So that shows off the caching capabilities where we won't regenerate an ISD file if we send the same label. It will merely grab it from the caching server and return it right back to the client. So let me look back here at the final demo thing again. That concludes the first test. We're going to go for our second test. And so I'm going to walk through the code. So I'm going to show the web service code here. This is the entire web service code. And then I'm going to show that it was written in Python. So I'm going to go ahead and close this web service so we can just look at this real quick. We can see that the command used to run this, UVcorn ISD app API.app reload, it runs this ISD API or ISD API.py file, and that .py indicates that it was written in Python. And if we look at the code here, if you have knowledge in Python, you can see that this was written in the Python language. So that checks off that requirement. And then I'm going to show the DynamoDB implementation for caching server. So originally when we created this acceptance demo grade sheet, DynamoDB was locally hosted, and we would show that in the code itself, like setting up the table. But since it's AWS hosted, you already saw me deploy this stack, and you can see that I have the table running on this AWS server. While I'm here, I'm going to show a quick live count. So this is just for the test one. This shows that we only generated one ISD, even though we sent it two label files. So we didn't generate two things. We only generated one, and then we returned the second ISD request based off the cached previous one. That's just a callback to the first acceptance test. But anyway, as far as the second acceptance test goes, you can see that we did deploy the AWS DynamoDB instance, and in the code itself, you can see that we connect to this using environmental variables, and we connect to the table itself using the Boto3 client, which is a provided AWS library for interacting with AWS services. And you can see right here, we specifically named DynamoDB. So you can see that we're connecting to the DynamoDB instance. So now if we go back here, we're going to show the getISD function to prove it's a RESTful API. So we'll just show that we have like a singular endpoint that returns an HTTP response and nothing else. So we can see right here, this is our getISD function. This is the endpoint /getISD. So this is the API endpoint. And this request here, we receive an HTTP request with a compressed byte stream of a label file. And then down here, we return an HTTP response, which contains a compressed byte stream of an ISD file. So this is a API endpoint that shows that it's a RESTful API because we don't receive any information. We merely receive an HTTP request and we return an HTTP response. And then I'm going to show the mini label and hash creation mechanisms. So right up here, we get that response in, we decompress it, and we decode it to get a label string. And then right here, we create a temporary label. We write to right there because we need to have a label file in order to create an ISD file, because the ISD generate command requires an actual file to generate from. So we store this label file we get in a temporary file called temp.label. And right here, we call mini label on that temp file. We call create mini label. And then right here, we call create hash on the mini label that's generated from that. and I will show these two files, or these two functions right here. So first we have the create mini label file. It takes an input file, it reads that in PVL, which is what all the label files for ISD generations are written in. They are called PVL files, so we have to use a library called PVL to load it. We load it as a dictionary. We remove everything but specifically the things we want, which are core, instrument, band, bin, and kernels from that dictionary. And then we add a label dictionary to that, or we add a label object to it, excuse me, and return this as a string. So this is the mini label creation. This is the whole mechanism for creating a mini label. And then down in the code again, you can see after we create that, the mini label string is saved as mini label, and we feed that to the ISD or the create ISD function and store that as ISD hash. So this is the create hash function. It takes in that mini label string we were just talking about, and it uses hashlib to encode it and turn it into a SHA-256 hashing algorithm. Then it turns that into a hexadecimal parsed version, and then it returns that. So this is the entire hashing algorithm. See right here. We'll show that the ISD is stored in the caching server using hash ID for a queryable format. So if we go back to the code, so right here, as we've been talking about, we just generated the mini label in the hash. The mini label doesn't matter anymore because we have a hash generated from it, which is the whole point we generated the mini label. So now you can see that we are going to check if the ISD is stored in the server already under the hash. And if it is, then we will just return it because we just got it back. If it isn't, we check for it right here, and then we run through the whole ISD generation process. But you can see right here, when we actually do generate an ISD, we store it under the table as an item, and we have the ID in the ISD. The ISD is the JSON ISD object itself, or the Python dictionary in this case. But this ID right here is that ISD hash we generated earlier. So we're storing each JSON, or we're storing each ISD in the caching server as a Python dictionary, and we are giving them the ID as the ISD hash so that we can easily look for it again. So if we want to look through that list, like if we already regenerated an ISD, or we already generated ISD and we send the same label file instead of regenerating it, right here, as I just said, we'll check for it first, and we check for it by searching through that table using the hash. So that's using the hash as a queryable format for ISDs. And then we'll show that it is returned, the ISD is returned to the client using a compressed byte stream for reduced data footprint. So right here, as we said, after we check if it's returned, like we check if it already exists and we return it, or we generate it. If we generate it again, or we generate it for the first time, I mean, we get it back, we check if it's the same thing. This is the exact same check as this one, like right here and right here. This just returns whatever exists at that index on the table. So if we search for it by the ID right here, we'll get it back and we don't have to do all this. If it doesn't exist, the server response will say that it doesn't exist, and it'll just have metadata saying an item doesn't exist there, which this checks for, and then it returns everything. So after this whole section is run, we've gotten back an ISD from the server. So now we're going to pop off all of the extra info, like all the server response metadata, and then we're going to pop off the wrapper for that, so that all that is left in this dictionary is just the ISD data we want. We're just going to parse it, which is some behind the scenes stuff about how DynamoDB stores stuff. That's not important for showing off what we return. This is just here because we need to do that to make sure the ISD is in the correct format. We're going to take that dictionary, that Python dictionary, and we're going to JSON dump s it, which means we're going to turn it into a JSON string. So it's a JSON object represented by a string. And right here, we're going to take that string and we're going to encode it. That turns into a byte stream. and then we're going to broadly compress that byte stream, and now it is a broadly compressed JSON byte stream, like encoded JSON ISD object. And then right here, this is what we're looking for. This is the return response. So this shows that we're returning an HTTP response, and the content is that compressed byte stream, and the media type is an octet stream, meaning that the HTTP response knows that it's a byte stream, and it's letting the client know that we're returning it a byte stream. So that shows off that it is returned as a compressed byte stream for reduced data footprint. And that concludes both demos. Um, yeah, excuse me. I guess when I ran it again for the first demo, I was actually running the second demo. I just misremembered that was part of the second demo because I showed off the running it once in the ISD generation, and then I misspoke and said I was running it again, and it wasn't in this, but it actually is. The memoization test, that was when we ran it a second time, and it generated everything, or it didn't generate it, it just merely returned it, and I showed that it didn't generate it from the web service, it merely cached it. So if you want to go back and look at that section, that's that's this whole test right here. I just misspoke and said that it wasn't included, but it actually was. But that concludes all three tests for the acceptance demo. Thank you for watching.